Okay, so today we're diving into a really fascinating research paper that lays out a completely new blueprint for building smarter, more capable AI. We're talking about making the leap from AI that just talks to AI that can actually do things. And this paper? It suggests a fundamental shift in how we get there. Let's break it down. So, here's the plan. We're going to start with the big challenge of creating these so-called agentic AIs. Then, we'll look at a really deep-seated problem in how they're usually trained. After that, we'll get into the paper's brilliant solution and the secret sauce that makes it all possible. And of course, we'll finish up with the incredible results and what this all means for the future of AI. For the longest time, the big push in AI has been all about making large language models better and better at just, well, language, understanding it, generating it. But the next real frontier, the next major leap, is creating AI that can take all that knowledge and actually use it to get things done in the world.
And that really brings us to the core question driving this whole field of research. How do we actually upgrade a super powerful language model into a truly autonomous assistant? One that doesn't just give you an answer, but can actively go out and take steps to find a solution on its own. Now, this paper zooms in on a specific and, frankly, super powerful kind of agent that they call a deep research agent. Just imagine an AI that has its own little toolbox, with a web browser, a search engine, a code interpreter, and it knows how to use all of them completely on its own to handle a really complex research task from beginning to end.
So, you might be wondering, why haven't we seen a flood of powerful open-source agents that can really go toe-to-toe with the big proprietary ones? Well, these researchers argue it's because of a hidden bottleneck, a really fundamental flaw in the way we've been trying to build them.
This quote from the paper really gets to the heart of it. So what on earth does that mean? Basically, your standard AI model doesn't think like an agent from the get-go. It doesn't have what the paper calls agentic biases, these built-in instincts for planning and tool use. This means we end up trying to teach it two totally different and really hard things at the same time. One, how to be an agent, and two, how to follow our instructions. The paper calls this an optimization conflict, and it's like trying to teach someone to ride a bike and do advanced calculus simultaneously. It just doesn't work well.
So here's what the old pipeline looks like. Step 1, the model gobbles up a huge chunk of the internet to learn general knowledge. Then, in step 2, this post-training phase, we try to just cram everything else in at once, teaching it how to act like an agent and how to be an obedient assistant. It's messy, it's inefficient, and as it turns out, it's just not the best way to do it. All right, so to fix this mess, the researchers came up with something brilliant. They propose adding a new, absolutely critical middle step to the whole training process. You can think of it like a specialized boot camp for the AI, where it learns all the fundamentals of being an agent before it even has to think about following specific commands.
And here it is. This is the new pipeline. They've wedged two new stages right into the middle, called Agentic Continual Pre-training, or Agent CPT for short. This is that boot camp. The entire goal of this stage is to instill those agentic inductive biases we talked about. It's literally teaching the model the fundamental instincts of how to plan, how to reason, and how to act like an agent before it's ever given a specific mission.
Okay, but a boot camp is only as good as its training manuals, right? The real secret sauce here, the thing that makes this whole new stage work, is a super clever and scalable way of creating just tons and tons of agent-specific training data.
And this is the huge hurdle they had to clear. Creating high-quality data that shows an AI how to use tools is incredibly expensive and slow if you have to actually run the tools live for every single training example. It would take forever and cost a fortune.
So, their solution is this really clever two-part data factory that, get this, works completely offline. On one side, you have first-order action synthesis, or FAS. Think of this as the mass production line. It takes simple facts and turns them into millions of basic if-this-then-that style planning scenarios. It's all about quantity. Then, on the other side, you have higher-order action synthesis, or HAS. This is the advanced strategy department. It takes a problem that's already been solved and shows the model all the different ways it could have been solved, teaching it how to weigh its options and make smart decisions. So FAS gives it the raw volume, and HAS gives it the sophisticated decision-making quality.
Okay, so the theory is solid. The new pipeline is in place, and they've got this incredible data engine. But does it actually work? Let's get to the results and see how the model they built with this method, Agent Founder, actually performs in the real world.
So the team trained up a 30 billion parameter model, which they named Agent Founder. And they didn't pull any punches. They threw it right into the ring against the current heavyweights of the AI world, including both the best open source models out there and some of the top-tier proprietary, closed-sourced agents.
And the results are just staggering. First up, on the HLE benchmark, which is all about expert-level knowledge, you can see Agent Founder's bar right there at the top. It is the first open-source model to ever break that 30-point barrier, a brand new record.
Then you look at the Frames benchmark, which tests really complex reasoning, and honestly, it's not even a fair fight. Agent Founder doesn't just squeak out a win, it demolishes the competition, setting a new state-of-the-art by a huge margin.
And to top it all off, on the Gaia benchmark, which is for general-purpose AI assistance, it does it again. Another new state-of-the-art score. So yeah, the pattern here is pretty undeniable. This method works, and it works incredibly well.
Look, these scores are amazing, but the story here is actually way bigger than just one new champion model. Let's talk about why this research really, truly matters for the entire field.
Because what's really important to understand is that the star of the show isn't Agent Founder itself. It's the recipe they used to create it. What this paper gives us is a new, proven blueprint that any lab in the world can now follow to build much more powerful and capable foundation models specifically designed to be agents.
So let's just pull this all together. What are the big takeaways? First, adding that Agentic CPT bootcamp step into the training process is a complete game changer. Second, those clever data synthesis methods, FAS and HAS, are the engine that makes the whole thing practical. Third, this blueprint is proving that it can seriously close the performance gap between open source and proprietary models. And finally, and maybe most importantly, this creates a much, much stronger foundation to build on. The next generation of agents built this way could be even more powerful than what we're seeing today.
And that really leaves us with one final massive question to chew on. Now that we have a better, more effective way to build these autonomous agents, what are the really complex, really messy, real-world problems, in science, in medicine, in engineering, that have always been just out of reach, that this next generation of agents might finally help us solve?